Welcome, my dear student. How are you? I hope you are all well and your health is good. So, today we learn about a new topic, simple harmonic motion. Now, you all know about the simple harmonic motion. इसमें नई क्या है? हम लोग तो जानते हैं कि सिंपल हार्मोनिक मोशन क्या है. तो आज मैं कुछ ऐसी इंपॉर्टेंट चीज़ें बताऊंगा कि वो आपको बहुत ही कॉन्सेप्ट जो क्लियर है उसमें बहुत ही हेल्प करेगा. अगर कॉन्सेप्ट क्लियर नहीं हुआ तो इन एग्जाम you will be get more difficult to answer numerical questions in joint or NEET. So today we shall learn this topic. First is what is SHM, what is periodic function, difference between periodic function and oscillations, and how to identify periodic or harmonic function. Is all periodic function is harmonic or not? So today's video we shall discuss the following chapter. So without wasting time, let us start. Now what is periodic motion? What is periodic motion? We know that when a body repeats its motion at a regular interval of time, it is called periodic motion. When a body repeats its motion over and over at a regular interval of time, it is called periodic motion. When a body repeats its motion over and over, this is S, its motion over and over at a regular interval of time, it is called periodic motion. Example, what are the example? First example is the motion of a pendulum in a clock. Number 2, mass is hanged from a spring. This is the example of periodic motion. Now, what is oscillation? What is oscillation? Now we go with oscillation. when a body moves to and fro, that is back and forth, about a mean position, when a body moves to and fro means to the mean position or away from mean position. When a body moves to and fro about a mean position, it is called oscillation. Sorry. If a particle is stable at point O, that is the force exerted here is 0, F equal to 0. Now due to some external force, this is go to point A and passing through the point O, it is come to B, and this is repeated for a regular time interval. So this point O is called mean position, and the motion of the particle is called oscillation. Now the question is every periodic motion is oscillations or not? Every periodic motion is oscillations or not? क्या लगता है? हर मोशन ऑसिलेशन होगा और पीरियोडिक मोशन होगा? अगर हम एक एग्जांपल ले लेते हैं दैट our earth is revolving around sun. If our earth is revolving around sun, then at a regular interval of times it revolves around the sun. This time is 1 year or 365 days approx. This motion is periodic motions. This motion is periodic. But this is not oscillation. This motion is not oscillation. This motion is not oscillation motion. Because the earth does not move to and fro about a mean position. It only revolves around the sun, but it does not move to and fro about a mean position. So the rotation of earth is periodic but not oscillatory. So we can say that every periodic motion cannot be oscillations, but every oscillation must be periodic. Every oscillation must be periodic because it passing through a fixed point, what is called mean position, at a regular interval of time, and back and forth the mean position. So the oscillation is periodic motion, but every periodic motion is not oscillations. Now, how can we say that any function is periodic? Therefore, how can I say that any function is periodic? So we can now know periodic function. If a function f of theta satisfies the condition f of theta plus t, then it is called periodic function. That is, at a time period t, the function f of theta repeats itself. That is the value of f of theta remains same at a time period t equal to twice pi divided by omega. Sorry, this is omega. So the value of f of theta remains same at a time period t equal to 2 pi omega if f of theta plus t equal to f of theta. That is, for sine and cosine function, this is cos of this time period is twice pi. That is, cos of theta plus 2 pi is equal to cos theta and sine of theta plus 2 pi is equal to sine theta. That is, at a time period 2 pi, cos theta and sine theta repeats their value, same value, or repeats their function. So we can say that this function is periodic. Now, in this case, we can say that we can use the Fourier theorem. For 11 student, this is not so important, but you have to know this Fourier theorem, which says that any function can be represented as a sum of sine or cosine functions fnt and gnt. That is, if f of t is a function, then it can be written as b0 plus b1 cos omega t plus b2 cos 2 omega t plus b3 cos 3 omega t and so on, plus a1 sin omega t plus a2 sin twice omega t plus a3 sin of 3 omega t and so on. This is the basic formula of periodic function, Fourier theorem, where b0, b1, b2, b3 are called Fourier coefficient. Now, if we summarize this value, what we can get? We can get b0 plus summation over n bn cos n omega t plus summation over n an sin of n omega t, where n take integer value 1, 2, 3 and so on. So any function f of t can be represented as a sum of sine and cosine function. Now let us, for a while, we can say that all the Fourier functions except a1 and b1 is 0. Then what can we get? F of t equal to, all the Fourier coefficients are 0, b0, b2, b3, a2, a3, all 0. So we can get only b1 cos omega t plus b1 cos omega t plus a1 sin omega t, or b1 cos omega means 2 pi by t plus a1 sin twice pi by time period into t. So this is the basic formula. So any functions which is represented so you can say that any function which can be represented by a single sine or cosine function is called periodic function. I hope you understand this. If any difficulties occur to understand, please write me in my comment box the particular position which you don't understand. Please see my all videos till the last end, because this is my first YouTube channel and I did not express my words so easily. So in a single view you can be seems that this is boring lecture, but if you till the last end of the video, you will definitely get some important points which you make you better understand and make you good result in the future. So please keep watching my video and subscribe my channel. So any function which can be represented by a single sine or cosine function is called periodic function. Now I can go with some example. अगर सिंगल साइन और कोसाइन वेव सिंगल साइन और कोसाइन फंक्शंस में किसी फंक्शन को रिप्रेजेंट नहीं किया गया तो वो पीरियोडिक फंक्शन नहीं होगा. सो if we take that sine of omega t plus cos of omega t, we can check that this is periodic or not. Sine of omega t plus cos of omega t. How can we check this? एक फंक्शन हमको दिया गया है कि साइन ओमेगा टी प्लस कॉस ओमेगा टी, हमको चेक करके बताना है कि ये पीरियोडिक है कि नहीं है. कैसे हम कर सकते हैं? सो सिंपली वी कैन राइट t as t plus twice pi by omega, that is t plus capital T. So if we write sine of omega t plus twice pi by omega plus cos of omega t plus twice pi by omega, then what occur? Sine omega t plus omega cancel 2 pi plus cos omega t plus 2 pi. Now we can earlier said that sine theta plus 2 pi equal to sine theta and cos theta plus 2 pi equal to cos theta. So any function which is increased or decreased by by 2 pi is repeat itself. So we can write it as sine omega t plus cos omega t. So it repeats its original value. So this function must be, so we can say that the function is periodic with time period what? 2 pi by omega. The function is periodic with time period 2 pi by omega. Now and this function, that is sine omega t plus cos omega t, is also harmonic function because it is represented by a single sine or cosine wave. Now if we say that sine square omega t, this is SHM or periodic or both, how can we say? So for this we can write it as sine square omega t, but sine square omega t has no definite formula. We have to take a value half into twice half into 2, that is 2 sin square omega t has a formula, half into 1 minus cos of twice omega t. Now if we open the bracket, half minus half cos of twice omega t. So this is a periodic function. If we periodic function with time period 2 pi by 2 omega, that is pi by omega. If we put t equal to t plus pi by omega, then we can repeat the value half of cos omega, half of cos 2 omega t. But due to this half term, this is not represented by a single cosine wave. This is a constant term. So it is not simple harmonic motion. For simple harmonic motion, it is represented by a single sine or cosine curve, but here this half factor is disturbed to represent this as a single sine or cosine. If this is equal to only cos 2 omega t, then this will be simple harmonic motion and periodic motion. So this is periodic with time period t equal to 2 pi by 2 omega, that is t equal to 2 pi by omega, that is time period t by 2, its time period is t by 2. But it is not a simple harmonic motion. In this way, we can understand that a function is simple harmonic or periodic or non-periodic function. So I hope you understand my lecture. In the next day, I details discussion with the theory of simple harmonic motion and its numericals. If you like on. Thank you.